Hey guys, what's happening? Welcome to our next video in our functions unit. Today we're talking about discrete versus continuous functions and interval notation. What you should be able to recognize, what you should be able to do by the end of the lesson today. You should be able to express a continuous set of numbers in interval notation. You should be able to recognize the difference between discrete and continuous functions. And you should be able to recognize real-world situations that are discrete versus continuous. Alright, so first of all, interval notation is just kind of the accepted way to write a span of numbers when we're talking about functions. So you guys are used to inequality notation when we're using our four inequality signs. Okay, so for example, negative 3 is less than or equal to x, which is less than 5. We've seen this before. That would be the thing from negative 3 to 5, including negative 3 and not including 5. But we're looking at all the numbers in that span. Okay? Now, because math people are lazy and we don't want to have to write out that every time we're looking at a function, every time we're looking at a graph, we've come up with interval notation. And what interval notation is, it's a way of writing this simply. Now we use parentheses and we use square brackets instead of inequality signs. Okay, so parentheses mean not included, and square brackets then mean included. Okay, so if I were to write this compound inequality, negative 3 is less than or equal to x, which is less than 5, it would just be from negative 3 to 5, including negative 3, so there's a square bracket there, and not including 5, so there's a parenthesis. Alright, so these two things mean the same thing. So for a closed interval, that's when we're going from one number to another number, and both of the dots on those numbers are closed. We want to include both of those dots, so we would use two square brackets. And then this is what it would look like in inequality notation, which you're a little more familiar with. For an open interval, both the circles are open, so we would use parentheses, and there's our inequality notation. For a half open interval, half the points that we're stopping at are open. We want to include half of them, we don't want to include the other half, so one of our n numbers would have a parenthesis, one would have a bracket. And again, this is what it would look like in inequality notation. And there are also times when, in inequality notation, we have x is less than or equal to some number. Alright, that's called a closed infinite interval, because it goes all the way from negative infinity, it goes all the way to the left on that number line, so it goes all the way from negative infinity up to a, and a is a closed circle, so we want to include a. For an open infinite interval, we're at an open circle, so we don't want to include the number, and we're going all the way to the right this time, so we're going all the way up to infinity. Okay, so it goes b to infinity. And this is how they would look in inequality notation, which you're, again, a little more familiar with. And if you notice, we always use parentheses instead of square brackets around infinity. And on the last slide, we had something like, I don't know, b to infinity, I don't know, something like that. And we use a parenthesis for infinity. The reason for that is there's not a specific number we want to include at the end of it. Alright, whenever there's a specific number we want to include, we use square brackets. There's not a specific number we want to include in infinity. That goes on forever, so we use a parenthesis. So now discrete versus continuous. A relation is discrete if it is made up of separate points. Okay, so only specific values are relevant. For example, if you go to the bakery to buy donuts, they're not going to sell you half donuts. Okay, so you could buy 0, you could buy 1, you could buy 2, 3, 4, 5, and so on. Okay, I couldn't buy 1.2 donuts. I could buy 1.375 donuts. Alright, so because these values don't have meaning in this situation is a discrete situation. Only certain values have meaning. They are distinct points. So some other discrete events might be stuff like buying frozen pizza. It might be number of students in a class. I don't know, something like that, when we're looking at a countable situation where we can't really have fractions where they don't really make sense. Versus a continuous relation. A relation is continuous if the points are not separate values. Okay? So, that means every number exists in between. Alright, that's what I was trying to say. So like, if a repairman says he's going to come to your house between 1 and 5, we want to include every possible time between 1 p.m. and 5 p.m. Okay, we want to include every possible minute in that. So he can come at 1, he can come at 2:15, he can come at 3:42, he can come at 2:45 and 12 seconds. He can come at any time in that span. So, because every amount of time is relevant in that amount of time, any amount of time is when he could show up. That's called continuous. Because we're looking at a continuous set of numbers. It's not something we can count, it's something that we can measure. Because there are infinite numbers of answers in a continuous situation. Okay, the possible answers continue through that whole span between 1 and 5. All the answers are continuous. So what are some continuous events? If I were to buy pounds of grapes at the store, grocery stores will weigh by half pounds and they will charge you by half pounds, stuff like that. If we're looking at my height, any amount of height counts. I could be 6'3.1 inches, you know what I mean? Any amount of height. So if we're looking at something that's measurable, it's going to be continuous. Something that includes fractions is continuous. Something that doesn't, something where we're only looking at specific points, that's discrete. Okay, so for discrete versus continuous, right here, we're looking at specific points on a graph. We're looking at 2, 8, 3, 7, 4, -3. Those are the only ones we're looking at. So this is discrete because all of these points are separate. They're separate points. Same thing over here. We're looking at a very specific set of x's and y's. We're looking at a very specific set of points. We're not looking at everything in between these. We're only looking at these points. So this is discrete. Whereas, if we had something like y equals x, that's a line, so we're looking at a bunch of points. Okay, so if we were to graph that, there's our axes, there's our line, there's the line y equals x. We're looking at all of these fractional points. Okay, there is a point at 1/2, 1/2. There's a point at 3/2, 3/2. Okay, so we're looking at a bunch of fractions there, and that continues from -infinity to infinity. So this is continuous because we're looking at all the values in a span, not just the specific points. All right, discrete, continuous. Now we're looking at a graphing situation. All right, right here, these are distinct points. Okay, and if they're distinct points, they're separate values. We're not looking at everything in between, so those are going to be discrete. Here, we're looking at all the fractions on this line. We're looking at every point on that line. So our options are continuous from one value to another value. And state the interval of continuity. We just talked about interval notation. So here, it goes on forever in both directions for our x values. So our interval of continuity is -infinity to infinity. Remember, we're using parentheses there. There's not a specific value we want to include. Right here, if we're looking at the interval of continuity, we hit every value from -4. That's -3. We hit every x value from -3 over to -1. So it's continuous. We hit every possible value, every fraction in that span of numbers, and we go from -4. Sorry, my bad again. We go from -3, and we want to include -3 because there's a point there, all the way up to -1. Because there's a point there. Those are the x values that we hit. Alright, so you guys should know how to write a span of numbers in interval notation and the difference between discrete and continuous graphs and situations. Write down any questions you have, bring them to class tomorrow. We'll get them sorted out. Have a good night, guys.